Now that we've figured out how to use molarity and calculate the concentration of diluted solutions, now we're ready to move on to the application of this. It doesn't really do us much good just to be able to calculate the moles or the volume or the concentration of a solution unless we're going to do something with it. First of all, if we're going to make a solution, that's helpful. But second of all, if we're going to apply what we know about the concentration of a solution to a stoichiometry problem. So far this year, the stoichiometry problems that we've been following have been following the path of going from from the grams of the starting material, grams of the given, and going through a series of conversions to the mass of product, the theoretical mass of the product. With solution chemistry, we're going to go about it in a slightly different path. And so one obvious example for us in this class is to go back to a lab that we did recently, and that was the Mission Impossible lab. And in this lab, you were asked to kind of loosely keep track of the amount of hydrochloric acid that you added to react with your carbonate. So here is the problem: calculate the volume of acid needed to react with 2 grams of your unknown. Assume, for the sake of this example, that you had strontium carbonate as your unknown. Well, of course, the first thing whenever we do stoichiometry is to write a balanced equation. So let's go ahead and do that. In this problem, we started with 2.00 grams of the strontium carbonate. And we reacted it for this lab with excess hydrochloric acid. We did that before we had learned about limiting reactants, and you were told to continue to add the hydrochloric acid until you knew that the reaction was finished. In this problem, we want to know what is the volume in milliliters of 3.0 molar HCl. Let's finish up our equation. Strontium chloride plus, as we learned, CO2 and water. When we go and balance this equation, it looks like we'll need 2 moles of HCl for every 1 mole of strontium carbonate. Now, if we think about the path that we're going to follow, we're beginning in the same place as we did when we did stoichiometry problems earlier. We're beginning with the mass of the strontium chloride. So this is our given, and the volume of acid is what we want to calculate. How much acid would we need to react all of it? Well, it depended on which unknown you had. Some of you needed to add more hydrochloric acid than others, and the reason for that has to do with the stoichiometric mole ratio between your unknown carbonate and the hydrochloric acid. So for this problem, the way that we'll begin is the same, but where we end up is someplace different. We are going to end up with calculating the volume of hydrochloric acid needed, beginning the same way, starting with grams, going to moles of hydrochloric acid, and then finally going to the volume of the hydrochloric acid. So with this idea in place, I challenge you to stop the podcast. See if you can actually calculate the volume in milliliters of hydrochloric acid. Once you get to the moles of hydrochloric acid, remember, you can always use the equation molarity equals moles over liters. And if you know the molarity, 3 molar, and you calculate the moles from this step above, then you should be able to determine the volume in liters of hydrochloric acid. So pause for a minute, challenge yourself to see if you can get to the end without looking at the answer. The more you can do this, the more successful you will be on tests. Step 1, convert the grams of your strontium carbonate to moles by using the molar mass derived from the periodic table. After you find the moles of strontium carbonate, use the coefficients in the balanced equation to convert the moles of strontium carbonate to the moles of hydrochloric acid. Once you know the moles of the hydrochloric acid, you could stop, calculate, and plug it into the molarity equation. Molarity equals moles over liters. But I suggest that another way is if you think about 3.0 molar and write it this way. 3.0 molar means 3.0 moles of HCl. Oh, that's in the numerator, isn't it? Per liter of solution. Well, if you take this ratio and turn it upside down, then your moles of HCl will be in the denominator and your liters, what you want to calculate, will be in the numerator. And that's what I've done here. Then I've allowed myself the opportunity to go from liters to milliliters, came up with the final answer of 9 milliliters of HCl. Happy calculating. Practice. That's the next step. Here are 3 sample problems that I want you to do tonight for homework. Put these on loose leaf paper, show your work, show each step. My suggestion, if you're struggling, is go and pull out your mole map, reread the podcast. You might need to go back and understand molarity if this is still a struggle for you. Notice that all 3 problems are given solution information with molarity. All 3 of them, you are required to write and balance the equation before proceeding on with your calculations. Word to the wise. Number 3, do you recognize it? Hopefully you'll see that it is indeed a limiting reactant problem. Good luck. Bring those to class tomorrow.